Welcome to the lectures on high voltage engineering. In today's lecture, we are going to study how to generate switching impulse voltage. In our previous video lecture, we discussed about what is an impulse voltage, what is the difference between switching impulse voltage, and what is the difference between lightning impulse voltage. So, if you are not familiar with what is an impulse voltage and what is a lightning impulse voltage, what is a switching impulse voltage, I will first suggest you to watch my previous video lecture. It is of short duration. First watch that video and then come to this video. This is yet another important video as well. So, how to generate switching impulse voltage? Remember, we are studying the high voltage engineering class. So, we have actually two methods for the generation of switching impulse voltage. The first method here is the impulse generator. So, impulse generator circuit is the circuit which we are going to study. It is a type of circuit which generates the impulse waveform, impulse voltage. So, we will modify a little bit so that we get the switching impulse voltage, because the switching impulse voltage is a type of voltage which is having the longer duration curve. So, in order to achieve longer duration, we will modify that circuit. And another method is using the power transformer. Now, power transformer is an AC transformer. How we can generate an impulse voltage using the power transformer? Well, we will excite the power transformer by a DC voltage. We will not do the continuous excitation of the power transformer. We will just excite it by DC voltage for a moment and then remove that DC voltage. So, the power transformer will then convert that DC excited voltage into the impulse voltage. So, power transformers are used in a high-end labs, in high-end test facilities, while the impulse generator circuit is the common or the most cheapest way of attaining the switching impulse voltage and to test your small insulations. So, what is an impulse generator circuit for the switching impulse for generating switching impulse voltage? So, let us see what that circuit contains. So, here we have actually two circuits. Okay, the first circuit I am going to draw here, it obviously we are going to generate an impulse voltage. So, it comprises of the capacitor which is going to charge, and obviously if this capacitor is charged, then there will be a charging resistance in series to that capacitor, and here we have a DC voltage, and obviously it is in kilovolts. So, once this capacitor is charged, we need to discharge that capacitor. So, here we have a spark gap, and then we have R1 and R2. They are variable, and they are what they are actually. They are not actually in a sense that we are going to vary. We will replace their values. We will replace resistors by different. They are not precisely variable. So, R1 and R2, these are the wave shaping resistors, and then we have an output capacitor and the test object. This is our test object. So, this is the simplified circuit of the this is the first circuit, and here you have the spark gap. So, what happens as soon as you apply the DC voltage, this capacitor gets charged, and once this capacitor's voltage level reaches equal to the supply voltage, what happens? This gap breaks. There appears there is a spark over. There is a spark over across this gap, and due to this spark over, what happens? This capacitor gets connected here, and these are the wave shaping resistors, and here you have the output. This is another capacitor which is obviously used to increase the duration to actually, it is actually a smoothing capacitor, but not a smoothing here, but this capacitor is actually, it is used to develop a tank, or I must say yes, it is used to develop a tank circuit. Not exactly the tank circuit. Purpose is to get some extra energy stored here, so that our waveform is for the longer duration next time. So again, let me discuss again the working. Once this capacitor gets charged, and when the voltage across this capacitor is more than the breakdown voltage of the spark gap, this capacitor automatically, there is a spark over across this gap, and it gets connected across this capacitor, across these wave shaping resistor, and across the test object. So what is the output voltage here? Here we have the output voltage. So the output voltage from this circuit is like this. You will first reach the peak value, and then there is a fall time. This is the peak value, and here you have the rise time, and here you have the fall time. It is also known as wave tail, and also known as the wave front. Okay, this is wave front and this is wave tail, and the total time these circuits actually generate the impulse voltage for as long as around 2500 microseconds. So this circuit can generate the waveform around 25 of the duration of the waveform is around 2500 microseconds, and the standard time for the impulse voltage is between 250 microseconds to the 2500 microseconds. So this circuit will be sufficient for generating an impulse voltage under this duration. If you are interested that you want an impulse voltage for the duration more than 2500 microseconds, because if you have more duration, the more area under the curve, the more energy you have here across the test object. If you want to generate such type of waveform having more wave duration, you can go for the power transformer and excited by DC, as we have discussed earlier. And what is another circuit? So in another circuit, what we are going to do is, things remain the same, but we add an inductor here. This is the second circuit of the switching impulse voltage generator. So how this circuit works, as we discussed earlier in our previous video lecture, that switching impulse voltage can be either of this type, or it can be either of a type that it has frequencies, it contains oscillations. Switching impulse voltage can also be in the form of oscillations. So an oscillatory switching impulse, how the oscillatory impulse is like this. This is a type of a switching impulse voltage which is oscillatory in nature. In the power systems, you can observe either the switching impulse voltages which are non-oscillatory in nature, or either you observe the waveforms which are oscillatory in nature. And since we have to test the object, if you want to test the object for the impulse voltage which is oscillatory in nature, so for that purpose we have added an inductor here. Now what is the purpose of this inductor? Again I will explain that here you are actually making the tank circuit. What does it mean? As you are well aware with the parallel LC circuit, if you have an inductor in parallel with the capacitor, and once they are charged, what happens? The energy flows from inductor to capacitor and from capacitor to inductor when they are resonating. So the energy keeps on flowing between these two sources ideally. So what here we have done? We have added an inductor here. So here things are in series. Now what happens? Once this capacitor gets charged, there is a spark over across this spark gap, and we get the peak voltage here. But since there is an inductor and capacitor, what happens? Again this spark gap breaks down. There is a spark over again here, and upon the next spark over, since this capacitor is not charged yet, so it is not playing a role in the spark over. As it is discharged here, what happens? There is a spark over across this gap, and we observe this peak. Again there is a spark over, and we observe this peak, because here this inductor and this capacitor, they becomes in series when in parallel when there is a spark over. When there is a spark over, this inductor and this capacitor are in parallel. So again, due to the spark over, we observe this peak. In the next spark over, we observe this peak. So until that there is no more capability of the spark over. So next time this capacitor comes in action and provides the spark over, and again this impulse voltage a new impulse voltage appears. So if you want a switching impulse voltage of this type, an oscillatory waveform, so you have added an inductor here. So these are actually the two methods of generating the switching impulse voltage which are commonly used. These are two circuits, and another circuit is about the transformer, the power transformer, which is excited by the DC voltage source. Thanks anyway.